Hey everyone, good morning. So here's the second problem. I just did the cherry pit video. Hopefully that worked out well. Here's the second problem, and I've cut out the individual steps, and I actually realized when I assigned it, I forgot there's actually a part C, so we'll go through that as well. Um, but I'll let you know what that is. It shouldn't be too hard for you to figure out. Um, so let's go through this one. And I will say about this one, this problem is actually asking you to do something I've never asked you to do before. So I want to see how you guys work through it. The couple submissions I've gotten so far have looked decent. Thank you guys for watching the videos. Thank you guys for following along. You can definitely tell the work I've gotten from people who have actually followed along and paid attention to the videos. It looks pretty good. Yeah, so keep that up. Also, when you're submitting pictures of your work, it's not that big of a deal for me to do it, but if you notice it's not really legible, if you double click on the picture, you'll get the ability to adjust the contrast and brightness of your picture. And if you fiddle around with those, you can usually make it so I can read the text a little bit better. But that said, it's not too hard for me to do. All right, everyone, so moving on, let's go ahead and look at our kickoff problem here. So I'm going to probably spend way too long trying to draw a kicker, because it's me. It wouldn't be me if I didn't do something like that. So here is, let's make the helmet just kind of going. So here's our kicker. All right, it's kind of, is that a football helmet? I don't even know what a football helmet looks like for a kicker anymore. Whatever. So here's our kicker. And they kind of get their hands behind them, right? And then here's this football. And I can't have his head be the same color as the football, so let me color that different color. It probably ought to just be fuchsia. All right, so here's the football. And we see, he's kicking the football, and so it's got those little speed lines behind it. Here, I'll put some little speed lines behind it. And we know that this football is traveling at 25 meters per second, and that's at an angle of 60 degrees above the horizontal. So we're asked for two questions, and I don't have them written down here. There actually are the components of the velocity, they are the hang time, and then part C, hang time, part C, which I actually accidentally cut off when I pasted it for you, is where does it land? All right, so this football, we know that the football is going to travel up in the air and then start to fall down. And we want to figure out how far will it go before it lands. So we've sort of broken the problem down here into three pieces. We're going to have to find the horizontal and vertical components of this velocity. We have to figure out how much time it spends in the air. And we want to figure out how far will it travel. So let's go ahead and lay out my constants. So I'm going to go ahead and say that the place the football starts, it's 0 for the height, 0 vertically, 0 horizontally. And we know that when it ends up 0 vertically as well. So over here, I'm going to make one of those horizontal, I'm going to make a horizontal vertical table. Horizontally, I know that it starts at 0, and I'm trying to figure out where it ends up, right? That's my goal. I don't know its velocity. We'll have to find that out. That's actually something we're working on. I believe that's part A, right? It has no acceleration, so that's easy. So that's good. So we just got to really figure out the velocity, and we have to figure out how far it travels. In the y direction, things are pretty similar. We know it starts at 0, right? Because it starts down here where he kicks it. Well, it's going to also land down here where he kicks it as well. So it ends up at 0 as well. So that's kind of interesting. It makes it both. As far as V naught, again, we don't know what that is. We're going to have to find that out. That's part A. Because we know we have 25, but this 25 is partially horizontal and partially vertical. So we're going to have to split that up. So we'll do that first thing. We do know that there is an acceleration. It's negative 10 meters per second squared. Ooh. Everything else? No, I think that's it. I think that's it. So we probably will have to find the time because that's how these problems work. Now, looking here, remember the goal is usually to take the side that's all the way filled out and use it to find this, and then find whatever you're ultimately looking for. And we have everything except for this velocity thing. So let's do that. All right, I'm going to hide all this. So when we're looking at our velocity, we know that our velocity here is 60 meters per second. Oh, not 60, sorry, 25. 25 meters per second. But that 25 meters per second is partially horizontal and partially vertical. So what we have to do is we have to do our components, just like we did our forces. Now, this is something that you can do with any vector ever. So we've never really been asked to do this with velocities before. But it's fine, we can make this work. We know that this angle right here is a 60-degree angle. So this is the opposite side. So here's our little triangle. This is the sine of the triangle. So that'll be 25 sine 60. And which means this one's just 25 cosine 60. All right. Given my skills on this little tablet that I'm using, there's no way I'm going to be able to write that in down here. So here's what I'm going to do is I'm actually just going to go ahead and we'll go ahead and calculate that out, and I'll put the actual numbers in there. So the answer to part A is just calculating these two things out. Let me pull up my calculator. So 25 sine 60 and 25 cosine 60. So 25, let's see, 60, and then I want to take the sine times, I get, for the 25 sine 60, I get 21.7, and we see that is the vertical. So 21.7 is the vertical part of my velocity, 21.7 meters per second. So yeah, we don't get all 25, we just get 21.7 of those meters per second. All right, back over to calculator. Again, so 25, 60, we're going to do the cosine. Oh, yeah, cosine of 60 is 0.5. I knew that. 12.5. Yeah, that'll work. So we'll keep that as 12.5. So the horizontal part of this velocity is 12.5 meters per second. Now you may be saying, Mr. Wimber, how do you add up 12.5 and 21.7 and get 25? Remember, you can't just straight up add these things. They're two-dimensional. We have to add them using the Pythagorean theorem. That's just the way numbers add when they're vectors like this. All right. So the 12.5 and the 21.7, those will be our two velocities. And look, now we have all of the information that we are looking for. All right, so let's go ahead and start doing some math here. I'm going to do some of the math over here. Let's switch to a different color so we can tell what's going on. Oops. I'm going to go ahead and try to find the time. So we want to find the hang time. Now, remember, the hang time is just when the position starts at 0 and ends at 0. How much time between when it's kicked and when it lands. So we want to find out, well, basically, we're just finding the zeros in a parabola. So in your math class, you probably know how to find zeros in a parabola. Yeah, I'm not going to worry about that right now. So you probably be faster at this than I will. So we know that y will be will be 1/2 at squared plus v naught t plus y naught. So that means 0 is equal to 1/2 times negative 10 meters per second squared, t squared, plus 21 meters per second times t plus 0. I'm going to go ahead, multiply through the 1/2 by the 10. I'm also going to move the 21t over to the other side. So I get negative 21 meters per second times t. It's going to be equal to negative 5 meters per second squared times t squared. I'm going to go ahead and cancel out the negatives. And look, oh, this is kind of nice. One of the t's cancels out. T cancels out, t cancels out. So what we end up left with is that t is just equal to 21 meters per second over 5 meters per second squared. And then units wise, the meters per second cancel out, but we're left with 1 second. And that second, because it's in the denominator, it goes to the numerator. So I'm just going to move it up here. And let's go ahead and throw this in our calculator. 21 over, oh, I just realized that my calculator's blocking stuff, sorry. 21 divided by 5, I end up getting 4.2 seconds. Sorry guys, I haven't gotten totally used to this thing here. I'm going to move my calculator off to the side, so. That'll probably get in the way there. I'll have it right over here. So we have 4.2 seconds as our hang time. So let's go ahead and zoom in. This must be 4.2 seconds, which, I don't know, if you watched a game of football, does that seem reasonable? Punter kicks something pretty high up 4 seconds before it lands. I think that seems possible. I'm not too surprised by that. All right, so let's go ahead then and do the second half. All right, of course I gotta move all this velocity stuff. So sorry, velocity stuff, I gotta get rid of you. All right, so we're gonna go ahead now and remember the way these problems work is you usually do fill out one side, use that to get the time, and then use that to finish up the other side. We've already done the first step. So we found the components to the velocities. That was part A. We found the amount of time that it was in the air. That's part B. That's 4.2 seconds. Now, the part that I cut off in your homework, so maybe you haven't done it yet, but I bet you could figure it out. Tell you what we're looking for now is where does the ball land? So if you've already had a chance to do that, go ahead, follow along. But if you want to, pause the video for a little bit. See if you can tell me where the ball lands. I'll give you a second. All right, so I'm assuming you've paused the video, you tried out the math, and have come back to it. So let's go ahead and do it. So we know here that because there's no acceleration, we get to use the simpler version of the equation, x equals vt plus x naught. We know that, well, x naught is equal to 0. We know that v is equal to 12.5. We know that t is equal to 4.2. Let me erase this. So 12.5 times 4.2. Let's move my calculator back over so you guys can see it. Oh, I'm just 52.5 is what I end up getting. So 52.5 meters. And again, does that seem realistic? That's about half of a football field. Does that seem realistic for a punter to kick something about half of the football field? I think so. I think that seems pretty realistic. I mean, I can't do it. I could, I can kind of do this sort of thing and probably hurt myself in the process. But I think a real punter could probably do that. Yeah. So to review the structure of the problem, what we ended up doing was we figured out all of our initial values. We had to first start by splitting up our velocity, the 25 meters per second, because not all of it's horizontal and not all of it's vertical. So we kind of have to do a little bit of both. But once we did that, it turns back into one of the old problems, like from earlier worksheets. It's once you do that, there's not really anything different to do. We solved for t using this equation right here, and we ended up getting the time here. And then we use that time to solve for v. So yeah, that's all we had to do. All right, everybody. Let me know if you have any questions. Please drop me an email or comment. I think I want to solve this problem again using graphs, because we've been so equation heavy of late that, I don't know, I like graphs. Graphs are pretty. So maybe I'll just reuse Zimmerline. All right, anyhow, let me know if you need anything. Classroom, email, Discord, stop by the Discord. And hopefully after spring break, you and I can have some more conversations. I'd love to say hi. All right, talk to you later, guys. Bye.